this page here. So we've got two types of equations we're going to write. These should look super similar to an ellipse, right? So I've got the center as my HK. I've got an x radius squared, a y radius squared. The only difference is you will either see a plus sign, here in front of the y squared term or in front of the x squared term. And that's what makes it different than an ellipse. With an ellipse, they would both be positives. Okay, so looking at the first example, I'm saying that it's a horizontal axis. And so what I mean by that is the ellipse is going to open sideways. Versus a vertical axis, the ellipse is going to open up, down on the vertical axes. So if we look at the horizontal axes here, you'll see this box. The box is not really part of the hyperbola, but it's a structure that will help us to build the hyperbola. Going through the corners of these boxes, you see these dashed lines. Those are our asymptotes. Okay, remember an asymptote is a line that the graph isn't going to cross or touch. So when I'm opening horizontally, right here is going to be a vertex, and I'm going to sketch my branch approaching but not crossing or touching that asymptote. So this is an example of a hyperbola that opens horizontally. The center of the hyperbola is in the middle of the box here. And the distance horizontally from the center to the vertex is my r sub x. And then the distance from the center down here to the bottom is going to be my r sub y. I only have two vertices. Okay, this is a vertex here, and this is a vertex here. This is just a point on the box that's going to help us to draw the box, but it's not classified as a vertex. All right, so, and with this little graph I have here, what's the center? 0, 0. So I have here a center at 0, 0. I have an x radius that's equal to 4 units. And I have a y radius that's equal to 3 units. So I have enough information to write the equation for this hyperbola. So we have our center is 0, 0. So I'm going to have, like, you can say x minus 0 quantity squared or y minus 0 quantity squared or just x squared, y squared. God bless you. We have our x radius, you told me was 4. So 4 squared is 16. My y radius is 3, so my 3 squared is 9. It's equal to 1. And then because it's opening horizontally, I need the minus sign here in front of the y squared term. So that would be the equation that would yield that hyperbola. All right. So if I look now at, here I've got this same box structure. The same box structure. But this time I want to sketch a graph of a hyperbola that's opening vertically. So I'm kind of drawing my branches here that are approaching but not really crossing or touching those asymptotes. My x radius is still 4. So when I'm writing my equation, this is still x squared over 16. I'm still having y squared over 9. This is still equal to 1. But this time, because it's opening vertically, the y squared is positive and the x squared is negative. In some textbooks, what you'll see is the positive term is always first. So if this, you could rewrite this. You could also say this is y squared over 9 minus x squared over 16 equals 1. All right, so some textbooks, you'll see it written like that. Yes, sir. So let's look here at example C. So these last two problems, this will be what you're going to see on your homework. All right, so if you're given the equation, let's start with the center. So first let's identify our HK. And what do we see here? -3, +1. We changed the sign of the H and the K. So I'm going to go ahead and graph that. -3, +1 is right here. My x radius is the square root of 4. My y radius is the square root of 25. So from the center, I'm going to go right to and left 2. From the center, I'm going to go up 5, 1, 2, 3, 4, 5, and down 5, 1, 2, 3, 4, 5. So now this is why I had you guys grab a ruler. With your ruler, I want for you to draw a box. Oops. What am I doing here? What happened? No. Oh, where's the X? What am I doing? Thank you. Oops. There you go. Okay.
There we go.
Thank you. All right, here we go. So I'm going to use my ruler to draw my box. Okay. So once you have your box drawn, then what you're going to do is you're going to draw your asymptotes. Okay, so your asymptotes need to go, let me hear my lines, from like the top left corner through the center through the bottom right corner. So something like that. And I can, oops, I have all kinds of, and then I'm going to do that again. Might draw my asymptote from the top right corner through the center through my bottom left corner. All right, let me clean mine up a little bit. Delete. Okay, so here's my asymptotes. All right, so now I'm ready to draw the branches of my hyperbola. Now, which way is this going to open? Is it going to open vertically up and down or horizontally left and right? It's going to open horizontally left and right. How do you know that? Because x squared term is positive, y squared term is negative. So my vertex is here, and I'm going to just sketch the branches approaching but not crossing or touching the asymptotes. All right, so this next one is not difficult. You just have to be a little patient. All right, so I can find the center. So what I'm going to do first is I'm going to mark my two vertices. My two vertices, here I have right here and right here. My center is halfway between those 2 points. All right, so how many units are between those two vertices? 8 units. So 4 units down from this top one, 1, 2, 3, 4, is my vertice, which is the coordinate 4, 2. And I know that now it was 4 units down, so my y radius is 4. All right, so I can fill out some of my equation. I have x minus 4 squared. I have y minus 2 squared. I know my y radius is 4, so I'm going to square that. And because this opens up and down, this is positive, this is negative. All right, now, so here's the only part, and it's not really tricky, you just have to be careful. I'm going to use my ruler, and it's going to be a little trial and error. Okay, so it's okay. So this is what I'm going to do. From my vertex, my top vertex, I'm going to put a point 1 unit to the right. And from my bottom vertex, I'm going to put a point 1 unit to the left. And I'm going to line my ruler up. Guys, don't draw the line, just because I can erase mine pretty easily. Don't draw the line. But if I were to draw a line there, is that touching my branch? Okay. So that's not my asymptote. So now I'm going to, where's my undo? Is that my undo? Where's my undo? There we go. So now I'm going to draw a point 2 units to the right and a point 2 units to the left. And I'm going to draw a line between those 2 points. Make sure it goes through your center. Yep. Hang on, mine's a little off here. So am I touching My branches, yes. So that doesn't work. So I'm going to go 3 units over. That should do it for me. So 3 units to the right and 3 units to the left. And if I connect those points, I'm going to take a gamble here and draw my dashed lines. All right. So there we go. Make sure, again, it goes through the center. I think we're close there. So 3 units to the right did it for me. So 3 is my x radius. 9 is my x radius squared, and this is opening vertically up and down. Now, it wouldn't be a bad idea to finish drawing it, especially just for our notes. So if I do point 3 units to the left, 1, 2, 3, 3 units to the left, 1, 2, 1, 2, 3, I think it's here-ish. And then I could draw my asymptote. And here's where, and you can check you can fill your box in. So your box hits here, and then up, and over, and down. So there's your box.